A very good morning to all. Welcome to Unacademy. Good morning, Piyush, Ayush, Harshit. आयुष जी की कोई डिमांड आई है? So if we have one indeterminate truss, then we cut section such that हमें reaction ना निकालनी पड़े. In some question left में support होता है तो वो सर राइट हैंड साइड से कर सकते हैं उन क्वेश्चंस को. आयुष, अगर ट्रस्ट इनडिटर्मिनेट है और एक तरफ सपोर्ट नहीं है, in that case you can solve the truss partially, not completely. Okay, for example, suppose this is your truss. It is an indeterminate truss. Okay, so it is an indeterminate truss, but you can solve this truss up to 1, 2, 3, 4, 5, 6. Up to here you can solve your truss. Even these two members you can find out. Okay, but this portion will be indeterminate. My dear friend. Okay, so for solving this portion, you have to either calculate the reactions, additional reaction, or anyhow you have to find this member force. A very good morning, Umol Khair Kazi. Okay, तो चलो स्टार्ट करते हैं. जस्ट ए क्विक इंट्रोडक्शन माय डियर फ्रेंड. आई एम योर फ्रेंड ऐश्वर्य. पढ़ाता हूँ आपको गेट एंड ईएससी के लिए. एंड फ्रेंड्स, माय एमटेक इज फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया. 4 times I have qualified GATE with my best AIR 226. And guys, I do have 6+ years of teaching experience and 2 years of industrial experience. And these are the subjects which I basically take on official Unacademy YouTube channel, Unacademy special classes, and Unacademy Plus. फोर्स पॉलीगन आयुष, इंटेंशनली मैं कोई बात नहीं कर रहा हूं उसके ऊपर, बिकॉज दैट इज रिक्वायर्ड अप टू सम एक्सटेंट फॉर ईएससी बट नॉट फॉर गेट. ओके, चलो उसके ऊपर भी ले लूंगा एक सेशन, डोंट वरी, है ना. डोंट वरी अबाउट फोर्स पॉलीगन राइट नाउ. Okay, and my dear friend, these all are the advantages of Unacademy Plus, that you will be having daily live classes, crash courses, you will be having a rank improvement batches. Courses are running on both the languages, English as well as Hindi. You will be having a dedicated doubt clearing session and weekly tests are also there. And my dear friend, please remember that this code is not only valid for GATE and ESC. Although I am a GATE ESE faculty, but don't think that code will be applied only for GATE and ESE field. It is the universal code at Unacademy. So whatever is the subscription, type of exam, you can always promote this code among your friends and relatives and they will be getting directly 10% off. Is it clear? Okay. So this is the schedule for the month of you can say September. So there are 2 changes in it. First, geotechnical engineering जो अभिषेक सर का है, that will be completing by 25th, and from 26th onward Abhishek sir is starting structure analysis in Hindi language. Okay, and engineering mechanics is postponed to 26th of September. In short, on 26th September your 2 subjects are starting. Okay, your 2 subjects are starting, engineering mechanics and structural analysis in Hindi. Okay, and RCC is also going on by Kshitij Sachan sir. Okay, so welcome to lecture number 50. आज हाफ सेंचुरी लगा दी हमने. ठीक है। सो 50वां लेक्चर है आज एंड अनाउंसमेंट इज सो आरसीसी live test 3 we are going to conduct today. Timing for that will be 4:30 p.m. to 6 p.m. and platform would be special class. It is special free class. To attend this session, you just have to download the Unacademy Learner app. After that, you can come live for your RCC test. Is it clear to all my dear friend? Chaliye, let's start. So, my dear friend, yesterday we have seen the concept of zero forces member and method of section. In fact, I have taken a numerical on method of section as well. So today I am going to discuss one more problem to cover the varieties on method of section, and after that I will be starting deflections in trusses. Deflections in trusses. So this is the agenda for today's class. Okay, is it clear to all? ठीक है, तो मेथड ऑफ सेक्शन से स्टार्ट करते हैं. सो मेथड ऑफ सेक्शन में हमने कल देखा दैट देयर वर 3 स्टेप्स. स्टेप नंबर 1 is the calculation of external reaction. Step number 2 that we have to cut our section, our truss into two parts. Okay, not necessarily equal. So any two parts we can break, and such that the maximum number of unknown in my truss is 3. Okay. After applying the equilibrium condition for a cutted portion, for an individual portion, for a sectioned portion, we will be able to find those 3 unknown at max. Okay, so at max we can afford only 3 unknowns. Is it okay? Okay. After that we have to repeat the procedure if we are looking for some other member forces, and like that we can solve the truss by method of section. So obviously method of section is very useful whenever we are needing forces in some particular member, like when we are drawing ILDs and etc. So in that we have to keep our concentration on one or two member, okay, at a time. So just by varying the position of load, so each and every time we have to find the forces in those particular members. So in that case, applying method of joint will be very long procedure. So we go for method of section. Okay, chali. So let me take another numerical on method of section. So let's start. Okay. Chinmay, I will suggest you to go through these lectures as well. So theory wise they are enough, but in these lectures I am taking more number of numericals. It is 2A, A, A, A. So it is a central point. Okay. So here you have applied a load. Let's say it is P. This is A, B. So question is, find forces in the member HI, HF, GF, GE, FD. Okay, so these many members you have to find. You are free to use, either you can use method of section, or you can use method of join, or you can use even the combination of them. Okay, so my dear friend, I need forces in 6 member. 1, 2, 3, 4, 5, 6. So please tell me the forces in these 6 member. Okay, so start कीजिए and let me know. चलिए, क्या कह रहे हो? गर्लफ्रेंड नहीं है आयुष? कोई नहीं, सिविल इंजीनियर हो, आई कैन अंडरस्टैंड. इट इज आई, GI. अच्छा, ओके, तो ठीक है. इतनी बेहतरीन हैंड राइटिंग है मेरी, इसके बाद भी कमियां निकालते हो. सो आई थिंक दीज 4 फोर्सेस, पहले 4 फोर्सेस, तो आप फ्रैक्शन ऑफ सेकंड में जवाब दे सकते हो. ओके, सो आर यू ट्राइंग गाइस? Okay, GE and GI are 0. Exactly. Exactly. Yes. First one is right. That see, this G is a joint. This G is the joint with no force acting on it. Okay. G is the joint with no force acting on it, and both the members GI and GE are collinear. So my dear friend, if these two members are collinear and no external force or reaction is acting at that joint, then both of these members are going to carry zero forces. Then both of these members are going to carry zero forces. अभी चलो इसको लिख देते हैं. It is the question, and now I'm giving solution. So here G is the joint which is carrying zero forces. Okay, which is carrying two non-collinear member and both of them are going to carry zero forces. तो क्या बताया था? जो नहीं है, simply remove that portion. Okay. Now come to joint number H. Now come to joint number H. You can see here. H is a joint. In this joint, force in the member HI and P are collinear, and HF is going to be third non-collinear member. So force on this non-collinear member is also going to be equal to P. It is also going to be equal to P. Okay. Okay, that's it. Okay, what next? So this you know. FHI 0, FHF FGI 0, FGE also 0, है ना? So both of these members were 0 and 0. So I am writing them 0 and 0. Even HF, even FHF is also 0. Even FHF, this one is also 0. Okay. Now what is next? Now HI. So H is a joint. You can say if you are going to apply here, summation of Fx is equal to 0 at joint H, then it is going to be equal to. So by default, every unknown force is tensile for me. So it is the free body diagram of joint H. Okay. So FHI plus P means tensile P. Okay. So HI member will be tension P. Okay. So these are known to us. What's next? AC, you are saying it is P. Okay. So anyone suggest me how to go for FD? First of all, tell me how we can obtain FD. So there are two ways to finding FD. First, uh, start from H, then you will come at I, then you will come at IE and IF, then draw the free body diagram of F, then try to find the value of FD and FJ. Okay, this is one approach which is lengthier. So here if you are using some short techniques, then what you can do here? So we can use here some short techniques. CEEJ, CEEJ, JF and FD. Very good, Ayush. Ayush is suggesting that, sir, what you can do, you can simply cut this section like this. Okay, but yesterday I told you we have cut the section in such a way that maximum number of unknowns are 3. But if I am going to cut my section like this, my dear friend, in that case, total number of unknowns are 4. But still, in this particular case, you will be able to solve the value of FD. You know why? Still, my dear friend, you will be able to solve the value of FD. You know why? Because when I'm going to cut my section like this, then you can see at joint F, three forces are passing FD, FE and EC. Oh sorry, FD, FJ and JE. So only EC is unknown. And if I am going to consider the equilibrium about E, then you can see EJ, JF and EC are passing through E, so their lever arm will be 0, so they are congruent. So we can simply create the equilibrium of FD with dP. So directly we will be getting the value of forces in the member of FD. Yes, yes Ayush, very good. And another approach is this, that you can divide your section even like this. Okay, you can divide your section like this. So this section is also having 3 unknowns, 1, 2, 3. So these two forces are congruent. Okay, so first of all, it is a long procedure. You can find the value of IE component about F by taking the equilibrium about this point. And once you know the value of this, then by using other equilibrium equation, you will be able to find Fj by applying summation of Fx is equal to 0 and summation of Fy is equal to 0, you will be able to get Fd. So by that also you can calculate the value of Fd, but that is a long procedure. So whatever Ayush has suggested, so that is going to save our time, my dear friend. That is going to save our time. So yes, so I am going to cut it like this. This. So I am going to cut it like this. Okay, so if this will be cut it like this, then okay. Now see here, this is unknown. Okay, and this is unknown. This is unknown. and this is unknown. So this is the required force. This is the required force, and let me call it F EC. Sorry, this is not required. This is the required force. What we can call it FFD. What we can call it FFJ. What we can call it FEJ. Okay. So simply take summation of mz is equal to 0 about A, about E. About this point, I am going to take the summation of mz is equal to 0. Okay. Because now you can see, if you are going to ignore this portion, then simply you can take the equilibrium of this section about E. Yes or no? So if you are going to take its equilibrium about E, then you will write F FD A and A into 2A. So this will be passing through E, this will be passing through E, this will be passing through E, plus P into A. This distance is how much? It is A. You can see here, P into this distance was originally A. Okay, is equal to 0. So FFD was coming out to be minus P by 2, means compressive P by 2. Yes. Is it clear? Is it clear to all my dear friend? Tell me. Okay. So next is FFD is minus P by 2. Similarly, if you need the moment, if you need the value of EC, suppose if you need the value of force in EC, then in the same cutted portion, my dear friend, you could have taken moment about F. For example, although it is not asked, but still we can find it, that if you are going to calculate summation of mz is equal to 0 about F, so what you can do, P into A, this will be 0, this will be 0, this will be 0 clockwise, and it will be minus FEC into 2A is equal to 0. So FEC is equal to P by 2. FEC is equal to P by 2. Is it clear to all my dear friends? So I can say here that here it would be compression of P by 2. This was 0 force member. This was 0 force member. This was 0 force member. And here there was a tension of P. Okay. This is P by 2 compressive, and it is P by 2 tension in this member EC. Now the next task is to find the force in the member AC. I hope you all know what to do now. I hope you all know what to do now. So when you have to calculate the value of CA, then in a similar fashion you can cut your section, but this time try to show your cut like this. Okay, you can make it like this. Is it clear to all? Is it clear to all? Okay. So if I'm doing if I'm making it like this, then so So it is A, B, C, D, E, F, I, H. A, B, C, D, E, F, I, J, K. ये ऐसा ही था? Yes. So this was 2A. A, A. So now I am going to cut my section like this. If it is so, then it is going to be look like this. Okay. So this is my force FCA, FCK, FDK, and FDB. So now if you want to calculate the value of FCA, then what you can do, you can take summation of mz is equal to 0 about d. Okay, so इसके about अगर moment लेते हो that it is 0, it is 0, it is 0, then anti-clockwise FCA into 2A plus P into A this and A this. FCA is equal to P plus P, so it is coming out to be tensile. Okay. Similarly, if you need the force in the member DB, then what you can do? Again, you can take the summation of mz is equal to 0 about D about C, then FDB into 2A plus P into 2A. So FDB minus P. Is it clear to all? Is it clear to all, my dear friends? Tell me. Okay. Okay. So let's proceed further. So now we have calculate forces in almost all the members. It is P tensile, P by tensile, and it is P compressive. So remaining forces, these diagonal forces you can calculate, not necessary by method of section, even by applying the method of joint. For example, here if you are drawing the free body diagram of this, then you can calculate IF and EF. And now if you are knowing FD, then making the free body diagram of F, you will be able to calculate FJ and FI. So like that, if you are going to use method of section and method of joint together, you will be able to find forces in all the member of the trusses. Okay. Now my dear friend, we will be starting deflection. So give the heading, very important, deflection in trusses. Again, you can say it is a very important topic. So for gate, if I am talking about, then method of section, method of joint, zero forces member, and deflection. If you are having a good command on all these four topics, then trusses is going to be a cakewalk for you. Okay. So give the heading deflection in trusses, my dear friends. See, one thing I can tell you, while calculating the deflection in trusses, you only have to be worried about for the application of method of joint. If you are comfortable in method of joint, then deflection is over. Literally it is over. Okay. The thing which you need here only the method of join. Okay, so let's see here, my dear friend. Suppose, okay, directly I'm giving you the expression. I'm not going into the derivation. So delta is going to be how much? It is pi ki li upon ai ei. That's all. Deflection is over. Or if somebody wants to apply the Cauchy-Lano theorem, then again you can write delta as summation of pi. Okay, so del pi over del p dash li ai ei. I belongs to 1 to n. That's all. But I will prefer that you should remember this only. So this you can say it is unit load method. It is unit load method, and it is Cauchy-Lano method. Both the methods are equivalent. Both the methods are equivalent, my dear friends. Okay, you can understand whatever is the value of del pi over del p dash, that is nothing but the value of ki only. So ki is equal to del pi over del p dash. Okay, so now let me explain you the terminology one by one. So I will be focusing on unit load method from now on. So this we are going to use. Okay, it is helpful. This unit load method is helpful in finding the deflection in trusses. And Cauchy-Lano we have already used in strain energy method while we were discussing frames and beams. So now see, delta is summation of okay. So here write this terminology very clear. Force in the ith member due to given load. Ki is force in ith member due to, you can say it is due to unit load, and unit load is applied in that direction where deflection is needed. Okay, unit load is applied in that direction where deflection is needed. Okay, and apart from this, Li, Ai, Ei are length, area, and Young's modulus of ith member of ith member. Is it clear? Okay. I am repeating it once again. This is the expression to calculate deflection in the truss by unit load method. So this expression is consist of these 5 terminologies. Pi is the forces in the ith member due to given load system. Okay, and Ki is the forces in the ith member due to unit load system. And unit load we have to apply it in that direction where deflection is needed. And L, A, E are the length, area, and Young's modulus. These are the length, area, and Young's modulus. Okay, and one important note here: whenever we are calculating PI forces, means forces due to given load system, at that particular time there should not be any interference of unit load. And whenever we are calculating Ki forces due to unit load system, at that particular time there should not be any interference of given load system. ओके, मतलब कि जब मैं पीआई निकालूंगा तो यूनिट का जिक्र नहीं करूंगा, और जब मैं यूनिट के कारण केआई निकालूंगा तो गिवन लोड सिस्टम को मैं वहां पे नहीं कंसीडर करने वाला हूं. ठीक है, तो ड्यू टू यूनिट लोड ओनली लिख देता हूं, ड्यू टू गिवन लोड सिस्टम ओनली लिख देता हूं. ओके, सो व्हेन पीआई आर कैलकुलेटिंग, unit load is absent. When Ki are being calculated, then given load is absent. So that is the concept here, my dear friend. Is it clear to all? Tell me. Okay. So let's see. So let me start from a very basic problem. So ABC is an equilateral triangle. ABC is an equilateral triangle. Okay. So let's say its length is A. Okay. So you have to calculate the vertical component of deflection at C. Question is, find vertical component of deflection at C if AE is constant and length of each member is A. Okay. So this is the question here. So how can we solve it? How can we solve it? Tell me. Okay. So delta we have to calculate here. So delta is summation of Pi, Ki, Li upon Ei, Ai, Ei. Okay. My dear friend, Pi, Ki, Li, Ai, Ei, we have to calculate for each and every member. Okay, we have to calculate it for each and every member. So the very best way to tackle such problem is to tabulate these quantities. For example, here you can see, let's say member, then you can see length of the member, AE of the member. Yes, Piyush. Step 1 is to calculate PI due to given load system. Step number 2 is to calculate KI due to unit load system. Okay, be careful while you are applying the unit load. Okay, then L and AI, EI are known to you. After that, PI, KI. Then simply you have to do PI, KI, LI upon AI, EI. Okay, so this you can tabulate always. So how many members are here? AB, AC and BC. So here length is same for all the members. Let's say it is A and A. Okay, and A is constant for all. A is constant, A is constant, A is constant. If A is constant, then better not to include it in the table. So simply calculate PKL, and in the last you can divide the entire PKL with AE. Okay, if it is constant. Okay, now the entire game is of calculation of PI and KI. Okay, so first of all let me concentrate on PI. Okay, so how we can find the value of PI? So step 1, calculation of PI due to given load system. Okay, so step number 1 is this. So this is my beam, oh sorry, truss. So due to this P, reactions here are P by 2 and P by 2. P by 2 and P by 2. And all these lengths were given A, A, A. and this angle was 60 degree. Okay, if this is A, this is B, this is C, then draw the free body diagram FBD of, let's say, joint A. Okay, so if this is your joint A, okay, so this is joint A, and if we are doing here summation of Fy is equal to 0, then you can say FAC sine 60 plus P by 2 is equal to 0. From here you can find FAC is how much? It is minus P root 3 by 2, isn't it? इतना ही आ रहा है क्या? नहीं, minus P by root 3 आएगा ना. Root 3 by 2, 2 to cancel, minus P by root 3, yes. So FAC, okay. And what about if I'm doing the summation of Fx is equal to 0, then FAC cos 60 plus FAB is equal to 0. Then FAC is how much? Minus P by root 3 into root 3 by into 1 by 2 plus FAB. So here FAB is P by, here FAB is plus P by 2 root 3. So AC and AB are known to you. AC and AB. AC is what? AC is P by root 3 minus stand for compression, and AB is P by 2 root 3 tension, P by 2 root 3 tension, and BC, from symmetry you can say BC and AC are going to be same, so it is also going to be equal to minus P by root 3, my dear friend. Is it clear to all? Tell me. Is it clear to all? Okay. So now come to KI system of forces. So here you have to calculate the vertical component of deflection at C. So my dear friend, remember the cases of strain energy in our beams and frame. We were applying pseudo load if required in such a direction in which we will be needing the deflection. So similarly, if I need a vertical component of deflection in my truss, then I have to remove first of all the given load, not only at C. Suppose A, B, C and more joints would have been there, and each of them was loaded with the given load system. So first of all, I have to remove all the given load, and I have to apply only that unit load at that location where I am needing deflection. So I will be needing deflection at C in the vertical direction. So my dear friend, I'm going to remove the P and I'm going to apply the vertical unit load here. Okay, for calculation of deflection. So just see here. So let me once again draw. So I'm applying unit load here. A, B, C. Okay. Similarly, if you are going to calculate the reaction here, it is coming out to be 1 by 2 and 1 by 2. It is easy, simply replace P with 1. Then you will be getting the following values. FAC is going to be equal to, if you are going to draw the free body diagram of joint A, then you can say that FAC is equal to minus 1 by root 3. Simply in place of P, substitute here 1. FAB is 1 by 2 root 3 and FBC is minus 1 by root 3. Okay. By chance, here the direction of given load and direction of unit load are same. So from unitary method, I simple calculate the forces for 1 unit load. So it is going to be minus 1 by root 3, minus 1 by root 3, 1 by 2 root 3. Okay. So now the PKL upon AE. So let me calculate that. P by 4, P by 12. So it is P, 4 is a 12. So PA upon 12 AE. It is PA upon 3 AE. It is PA upon 3 AE. So in this table, whatever is tension, I have to keep it positive, and whatever is coming out to be compression, I have to take it negative. So these are the PKL upon AE values. Fourth is a 12, 3 and 3. Okay. So finally, if you want to calculate deflection, then deflection is summation of this. So delta is nothing but the summation of this column. So it is equal to 1 by 12 plus 1 by 3 plus 1 by 3 of PA by AE, of PA by AE. So delta would be 12,144 PA by AE, 9 by 12, 3 by 4. Yes, very good, Piyush. Okay, so this is the value of delta. So the vertical component of deflection at C is equal to 3 PA by 4 AE. Please let me know, guys, whether you have any doubt here or not. Please let me know. Please let me know whether you are having any doubt till here or not. चलो क्लियर, ओके नेक्स्ट करते हैं फिर। नेक्स्ट क्वेश्चन। सो यस, सो आई एम गिविंग इट फॉर यू, ओके आई एम गिविंग इट फॉर यू। चलो एक गेट प्रीवियस ईयर उठाते हैं। लेट मी टेक द एग्जैक्ट डाटा, जस्ट ए मिनट। गेट प्रीवियस ईयर उठाएंगे, तो सॉल्व कर देते हैं। क्वेश्चन ही नहीं मिल, अच्छा ओके। थोड़ा डाटा चेंज कर देता हूं, वरना जिसको याद होगा आंसर। वन 150 किलो न्यूटन, ओके दिस इज ए, दिस इज बी, सी। So length is 4.5 meter, 6 meter, and this you know. Okay. आज लाइव लर्नर्स नहीं आया भाई, कहाँ चले गए आज? ट्रसेस क्या इजी है क्या, सबको आता है? Very few live learners are there today. Okay. So area here is given to you 1550 mm square, and E value is steel है, okay. So this is given to you, so you have to calculate horizontal component of deflection at C. So you have to calculate C पे horizontal deflection. वही तो मैं कह रहा हूं, तो रोज 10 से ज्यादा ही रहते थे। मुझे लगता है या तो सबको ही ट्रस आता है। चलिए कोई नहीं, यस धोनी साहब बता दिया जीरो फोर्स मेंबर के बारे में। एंड कल का वीडियो, परसों का लास्ट का 10 मिनट 15 मिनट है ना, लेक्चर नंबर 48 लास्ट 15 मिनट्स, एंड लेक्चर नंबर 49 कंप्लीट देख लो। जीरो फोर्स मेंबर का एक भी क्वेश्चन नहीं छूटेगा, दावा है मेरा, ओके। लेक्चर नंबर 48 लास्ट 15 मिनट्स एंड 49 कंप्लीट वीडियो देख लीजिए, एक क्वेश्चन नहीं छूटेगा जीरो फोर्स का, चैलेंज है मेरा ओपन। ठीक है। अरे वही तो मैं आपसे पूछ रहा हूँ, आज इतने कम लोग क्यों हैं? Either you guys are very much comfortable in you can say trusses. Okay, चलो चलो कोई बात नहीं, चलो हो जाता है, कभी कभी छुट्टी लेने का मन करता है सबका पढ़ाई लिखाई से। Okay, now give me the value of horizontal component of deflection at C. C पे horizontal deflection कितना होगा? This you have to calculate. Okay. So कितना टाइम में कर दोगे? चलो मैं स्टार्ट करता हूँ इन दी मीन टाइम। ओके ओके so I'm first of all I'm making here a table. AB, BC and AC, there are three members. So members and you can say Li. Okay, AI I'm not writing here. Why? AI नहीं लिख रहा मैं because AI is constant for all three members. So in the last I'm going to divide it by AI. Okay. So PI, KI and PKLI. Okay, in the last I am going to divide deflection by AE. So final deflection is summation of PI KI LI upon AI EI. So AI is constant, so it can be taken out constant. So it is 1 upon AE times of summation of. Okay, so देखते हैं कितना आता है members. So it is member AB AB BC AC AB BC AC AC. Okay, so L is 4.56 and by using Pythagoras theorem it is going to be equal to कितना हो जाएगा? 7.5 हो जाएगा, 7.5 मीटर, यही होगा ना 4.5 and 6. Okay, so 15.4 mm you are saying, Ayush? No. So 4.5 6 and it is 7.5. Okay, so 3 4 5 ठीक है ना, 5 से जा रहा है ना, ठीक है, 3 4 5 ट्रिपलेट. ओके, आफ्टर दैट PI. So now the PI. Okay, so here you can see that you can find the reactions here. So due to this 150 kilonewton load, even you can solve this question without calculating the, you can say, reaction, because C is open here. So this and this will be known to you. From there you will be able to find the reaction and all. Okay, so okay, you can also calculate reaction. So let's say this reaction is compressive, RB. Let's say it is RA. So one thing you can write, that summation of Fy is equal to 0 is equal to RA plus RB. RA plus RB is equal to 0. Okay. So after that, what you can do? After that, what you can do? You can take the summation of movement is equal to 0 about, let's say, A. B पे भाई horizontal भी आएगा, sorry. There would be horizontal force component as well at B, which is nothing but 150 kilonewton only, because summation of Fx is equal to 0. So if we are going to calculate summation of mz is equal to 0 at A, then it will be minus RB into 4.5 plus 150 into 6 is equal to 0. So what is the value of RB here? What is the value of RB here? Tell me fast. So 3 by 4. 200. Is it coming 200? Four by 3. Yes, 200. Yes. And RA would be minus 200 kilonewton. So in that case, you can say that RA and RB to be, yes Piyush, this is right. This time you are right. So Piyush, please help me in solving this quickly. This is 200 kilonewton and it is also 200 kilonewton downward. Okay. So now first of all, let me calculate PI system of forces. So step 1 is calculation of PI system of forces. Okay. ये आशीष भाई तो अपने अच्छे अच्छे अपडेट देते रहते हैं. जैसे ये तो बहुत अच्छी खबर बताई इन्होंने. कोरोना वैक्सीन इज सून गोइंग टू बी रिलीज्ड बाय रशिया एंड इंडिया. ओके आशीष, थैंक्स फॉर द अपडेट. ओके, पीयूष भाई बताते रहना. आशीष, you can also help me here. So AB, BC, AC. Okay. So this is so it is going to be 4.5, 6 and 7.5. So here they are applying the load 150 and here you are going to apply the load 150, it is upward 200, and it is downward 200. A, B and C. It is A, B and C. Okay. So this, if this angle is theta, then you know cos theta is equal to uh, 3 by 5, and sin theta is equal to 6 by 7.5, means कितना हो जाएगा? Is it 4 by 5? 15 चौके 60, 15 पंजे 75. Yes, ठीक है. So in P system of forces, okay. So let me start from the free body diagram of A. So FBD of joint A. Okay. So this is A, and this is 200, and by default each and every unknown forces for you are tensile. So tensile. So you can write here 200. You can write here FAB. You can write here FAC. This is theta. So you can say FAC sin theta minus 200 is equal to 0. So FAC 4 by 5 is equal to 200. So FAC is 250. So FAC is 250 kilonewton. Okay. And let me talk about AB. So in a same equation, I can also perform summation of Fx is equal to 0. So FAC, yes, cos theta plus FAB so FAB is minus 150. Okay, yes, tension minus 150. So I can write here, sorry, compression 150. So it is 150 compression. Even from G you can see, even by considering the equilibrium of joint B, you are very easily able to say, so this is a joint, this is 150, so it has to be 150. Similarly, it is 250, then it will be again compressive 250, sorry 200 compressive, है ना. B दब रहा है तो मेंबर भी क्या होगा, दबेगा with a force of 200. And AC, there is a tension, how much, 250. So AC is 250 tensile, and tensile is positive for us as per our adopted sign convention, and compressive is negative. Okay. Okay आशीष, करते हैं बात इसके ऊपर, फिर कभी रुक जाओ आशीष. सो PI इज हाउ मच, AB में कितना आएगा, AB इज 150. ओके, BC is 200 compressive, and it is tension 250. Okay, is it clear to all my dear friend? Tell me, is it clear to all? Okay. So after that, now come to KI system of forces. And similarly in this case as well, my dear friend, while calculating KI system of forces, what I have to do, I have to remove the external loading, which is this one, and I have to apply the unit loading, unit load. Unit load I have to apply in that direction, where actually I needed deflection. Since I need deflection in the horizontal direction at C, so I have to apply my unit load in horizontal direction at C. Is it okay? So see here. Yes, Arshit. Like in similar in earlier problem, I also did the same now. Instead of P, now 1 is applying. Okay. So I simply replace P by 1 or divide the earlier one with P. So similarly, if in place of 150, only 1 unit system is going to apply here, then it is also 1. Okay. So due to 150, it is 200. Okay. So how much increment is there? So similarly, you can simply divide 250 by 150. So your answer would be 4 by 3, or you can say 1.33. It is again 1.33. Not even for external reaction, but even for internal members, you can say. So when 150 was there, so tension was 250 here. So if it would have been a unit load, then it is 5 by 3. Then it is 5 by 3. 250 by 150 is 5 by 3. So what is 5 by 3? 1.67 tension. Similarly, when it was 150, it was 150. So it means when it is 1, it is also going to be equal to 1. So it is 1 compressive, and it is also 1.33 compressive. It is A, B, and C. Length is also known to you, same 4.5, 6, and 7.5. So now, my dear friend, what you can do here, so Ki system of forces is going to be minus 1 minus 1.33 and plus 1.67. Now multiply PKL, PKL, PKL. Shortcut नहीं है, unitary method है. So in linear elastic system, all those things are proportional. So what is the value of PKL, my dear friend? Harshit, Ashish, you can answer it fast. जल्दी बताइए. PKL for AB, BC and AC. Fast, fast, fast. So 150 into 4.5. 150 into 4.5. Yes. 675. Second is 200 into 1.33 into 6. 1596. And third is 250 into 1.67 into 7.5. It is 3150. If you are going to add all of them, then plus 5421, and the value of AE. AE is how much? 1550 into 10. It is mm 2 into 10 raised to the power 5. Newton per mm square. So it is how much? It is 31. क्या कह रहे हो? 3100 है. Yes. So it is kilonewton meter only. So it is 5421 kilonewton into meter divided by 3100 kilonewton. So 17.48 meter. Oh, sorry. It is equal to 17.48 millimeter or 0.017487 meter. Okay. So it is the final answer. Yes. So in mm it is 17.48. Is it clear? So the final deflection at C in the horizontal direction is given to you. Okay. Is it okay to all my dear friend? So my dear friend, tomorrow I will be taking one more numerical. I will be taking one more numerical on deflection, and then I will start arches. Okay. AC wrong calculated means AC कहाँ wrong है भाई? How Ashish? Okay. 3131.25. Yes. Ashish is right. So plus it is 5502. Thank you, Ashish. So 17.75. So it is 17 point. This is the final answer. सर एक क्लास डिस्कशन ऑन पीएसयू का रखिए सर. वी नीड योर ओपिनियन. आशीष आई विल ट्राई टू प्लान इट ऑन संडे. ओके. संडे को देख बहुत दिनों से मैंने कोई टेक्निकल सेशन के अलावा सेशन भी नहीं लिया है. तो सून आई एम गोइंग टू प्लान ए सेशन ऑन जर्नल डिस्कशन. ओके. अरे अब क्या हो गया? 17.7 नहीं आ रहा क्या? Okay. Yes. एक्चुअली मेरे पास ना कैलकुलेटर नहीं है, ये मोबाइल पे ही करता हूं मैं, तो इस पे प्रैक्टिस अभी है नहीं मेरा। कई बार सोचता हूँ कैलकुलेटर लेके बैठूं। दिस इज फाइनल। यस, दिस इज फाइनल। थैंक्स आशीष। चलिए, ओके ओके ओके। चलिए, थैंक्स अ लॉट आशीष, आयुष, हर्षित, टू ऑल माय ऑडियंस। माय डियर फ्रेंड, ट्राई टू कम लाइव इन मैक्सिमम नंबर्स, तभी मजा आता है क्लास के अंदर। ओके, आई डोंट नो व्हाट इज द रीजन टुडे ऑल ऑफ अ सडन वैल्यू ड्रॉप टू मच। मेरे को लगता है कि ट्रसेस में वेरी मच ऑफ यू आर कंफर्टेबल। ओके, so okay, we will keep a separate session maybe this Sunday or next Sunday, we'll see. So topic is डिस्कशन ऑन पीएसयू का रखना है। ओके, कल तो पहले आर्चिस कराऊंगा। आई विल बी टेकिंग वन मोर क्वेश्चन मे बी ऑन रोटेशन इन द मेंबर ऑफ ट्रस्ट, आई विल कवर टुमारो। ओके, एंड नेक्स्ट सब्जेक्ट इट इज कंप्लीटली सरप्राइज फॉर यू माय डियर फ्रेंड। ओके, देखते हैं क्या होगा। Okay, if any of my friend is interested in Unacademy Plus subscription for GATE and ESE and even for other fields, then you can always go download the Unacademy learning app and you can always apply this code AS10 in order to avail 10% off, my dear friend, which is maximum given by Unacademy. Okay, and you know the various benefits of Unacademy Plus subscription, like you will be having daily live classes, okay, doubt clearing session, weekend tests are there, courses are running on bi-languages, okay, dedicated doubt clearing sessions are there, etc. So lot many benefits are there. Nowadays Unacademy has even started your iconic subscription plan, so I will update you about that soon. Okay, and you can even pay in EMIs if you are not feeling comfortable to give all the fees at once. Okay, so that is also available now. Is it clear to all my dear friend? And this is my office, this is our official Facebook channel, this is our official Telegram channel. Okay, and soon I am going to give you my own independent Telegram channel very soon. Okay, let's wait for some time. So where we will be completely able to tackle your doubts, daily practice questions and all. And these are the various studies channel offered by Unacademy, and right now you are watching this. And if you have not subscribed this channel, then please do subscribe it by now. Okay, thank you my dear friends, thanks a lot. Okay, have fun, stay safe, don't go outside if it is not required. Have a great day ahead, my dear friends. And yes, don't forget to come live at 4:30 for the RCC live test 3. Okay, don't forget to come.